welcome everyone. We've got Will Yates, who's coming off his sick bed to do the presentation. Thank you so much, Will, for making the effort. It is appreciated. Normal rules apply. Delegates will all be muted, just because it makes too much background noise. If you've got any questions, if you pop them in the chat, I'll pick them up, Will, and try and find a moment to interrupt between foils or something.
That's great.
With the questions. I know you're an experienced presenter and you won't mind being interrupted.
No, not at all.
Try and leave some time at the end for questions. So without further ado, Will, please take it away.
Cheers, Rob. So yeah, as Rob said, I'm currently recovering or still in the throes of having a chest infection. I'm dosed up on paracetamol, decongestants and ibuprofen. So none of this is written in a fever-filled state. It's all real information. It's all accurate. But if I do mute myself during the presentation, that's because I'll be having a coughing fit in the background, and no one wants to listen to that, especially if you've got headphones on. So this session is about automated continuous integration testing of your hybrid cloud application. So for quite a long time, we have been talking, not just within GSE, but within IBM, with one-to-one with clients, about continuous integration, continuous deployment, how that supports Agile, and how that allows you to get code fixes into production faster. And it's a journey. It's a journey that we're all slowly moving along. And from a lot of the work I've done, we're very much still at the stage where we're looking at how we're going to do the code and build phases of that pipeline. Some customers are a lot further ahead, and some are still starting on this journey. But that section at the bottom, the test section, is, well, in my mind, one of the most important parts of the pipeline. If you don't have the ability to validate the changes that you're making aren't breaking your application, then it doesn't matter how quickly or how efficiently you can code, build, and deploy the product, because you're just coding, building, and deploying rubbish. Testing, being part of this pipeline, is vitally important. And it's important that the testing that is done is automated and not a manual process. The whole point of a CI/CD pipeline is that it is automated. Yes, there may be spaces within that pipeline where we have manual gatekeepers, where we need sign off on certain aspects, but the test part of that, there may be a test sign off that could be manual, but the actual process of testing and validating the product should be automated. And failing to have good, high quality automated tests within the pipeline will force your delivery engine to go back to being waterfall, because test will become an artificial bottleneck. Now, this is a problem not just for a hybrid cloud application, but for any application. The CI/CD paradigms match to any application. But when we start thinking about hybrid cloud applications and applications that are running on more than one platform, the complications around test become more obvious. So imagine I've got this application on the right. I've got a set of containerized applications up at the top right. So these could be running in OpenShift, they could be running in Kubernetes on a on-prem or off-prem cloud. And both of them have these red arrows pointing into them, and that denotes UI entry points. So I've got two UIs that I am exposing to my customer, and they are being powered by this containerized application. Now, one of these containerized applications feeds into a z/OS application, or uses a z/OS application to do its work. So this may be an SOA call, an API call of some description. Doesn't really matter. On the right-hand side, I may have a containerized application that's using some sort of mediator, like an ESB or an API discovery hub, to eventually call through to the z/OS application. And finally, I have my distributed application, an on-prem piece of distributed application componentry, which has its own perhaps internal UI entry point, and also uses my z/OS application. Now, when I say it's a UI entry point, this may be a GUI, it could be a web front end, it could be a 3270 panel, it could be a bespoke piece of Windows componentry. It doesn't really matter what it is, it's just that it's a way that a user will come into and use this application. And of course, my z/OS application has its own UI entry points. Now, a lot of those UI entry points, such as 3270, aren't as strategic, perhaps we would say, as others. If we were designing a brand new Kix application today, we'd probably be focusing on it being a non-terminal started transaction, and we'd be driving it over JSON APIs. But the interfaces and the UIs on that z/OS application are still important and still are being used by the business. So they still need to be tested as part of the entire application. Sorry, excuse me one moment. So let's look at just testing one of these containerized applications. What would that mean? Well, first off, it's very easy to deploy that containerized application. It exists as a binary immutable image. I can deploy it to either the platform that it's going to be deployed into, maybe under a test namespace. I could deploy it to an instance of OpenShift or IKS running on my machine. I can run that application pretty much wherever I want as part of my test in order to test it. Very easy, very straightforward to do. And then it is logically isolated for me for my testing. The language that the application is written in probably has an awful lot of unit test capability. That I've got a good set of unit tests that will run when I built my application, and those unit tests will mock out all of the dependencies between that application and my z/OS application. So right off the bat, I've got an application that has a good level of testing applied to it from that containerized application perspective. I know when it gets built, it has some tests applied to it, and they have passed, and then the containered image has been uploaded to our container repository. So I know it meets a certain level of quality. However, I also know that if my z/OS application has changed, then that containerized application may not have taken on the changes that would be introduced by that z/OS application change. So I need to be aware of that. But overall, it's probably the least of my worries. It was developed within the last 10 years. It's got a level of modernity around it that is going to be helpful. If we move on to looking at our distributed application, in terms of just how do I create a new version of this to test against? Well, I for the first time, I may not be able to. Potentially, I could have it running inside a virtual machine, or that I could clone and I could redeploy somewhere else to test against. Maybe I have a test instance of it somewhere that we can use, but how well updated is that test instance or that VM? How well isolated is it from everything else that's running, so I can be sure that I'm not going to introduce any problems by running my testing there? It's often going to be a stack of software. It's going to be a J2EE application sat on top of Webster Application Server, sat on top of something else. And that stack of software is then going to also bring in concerns and worries. Well, what if that stack's changed? What happens if it's brought any new dependency issues into the application? And where are the tests running? So I've got the tests for that application may be running within that application. They may be good unit tests like the containerized application, but when were they last run? If this is a VM, when was that VM last built? Were the tests part of it? So I'm getting to a more complex view of that of how to test that part of my application. And then if I look at my z/OS application, well, this is probably where I've got most of my concerns. I've probably not got a perfect virtualized z/OS instance that I can new up or I can provision as part of my testing that's just got the latest version of my z/OS application in there. The technology to do that exists. Things like IBM Z development and test, WASI as a service exist to do that type of work. But if I've not yet done that, then I'm probably stuck using a shared dev or test environment. And what about the application that I'm actually testing? Is there automated tests available for that application? Or are they all currently manual? What regression tests have I got to prove that if I change that application, everything else will still work? So this is probably one of my biggest main concerns. But this is just viewing the testing of each of these applications or parts of the application as separate silos. But the application itself does not run in a silo. It has these integration points. And it's those integration points that force the testing context to also grow. So my context is now moved from just being about the z/OS application, but to also include a containerized application or my distributed application. Now, in this application, we had 1, 2, 3 kind of main external entry points into our application. So that gives us kind of 3 different contexts, one from each of those applications. But the integration between all of these applications needs to be considered at some point. And often trying to test this can almost seem like an easier opportunity because, well, I'll just drive the same tests that I run in my containerized application, and I won't use the mock, and so therefore it should all work. And so this will often get boiled down to, well, we'll just run some API tests at this level. We've got load runner, we'll run some API tests, and if they all come back good, then that's great, that's fine. Well, it can be fine, but have we checked and have we validated that those API tests actually updated and changed the persistent state of our z/OS application? Can we be certain that every API call is actually going into the z/OS application and updating its state? Or is there a chance that that state could be cached within this containerized application and we will need to invalidate that cache, retest it? How can we be sure that the changes instigated in the system of engagement have persisted in the system of record? And the testing that we do may not even start from a user interface, like a web UI or a GUI of some description, but it may start from a component interface, like a message coming in from an ESB, a service call, a JSON API, as we discussed earlier. Now, in these cases, as these applications obviously are a lot more complex in real life, these kind of mediation layers, like in ESB or some sort of hub, could cause problems, because if I drive some workload through a containerized application that updates my z/OS application, and then I place a message onto this mediation queue to get a response back from the z/OS application, how do I make sure that this is all within the same test state? How can I ensure that the change I make here was persisted into the z/OS application and then was retrievable through the mediation layer? So even though I've got unit tests within my containerized applications, I'm still going to want to bring all of this together and have large running integration tests that span my entire application. It's also unlikely to think that all of these applications are going to move in lockstep with each other. Each of these applications in dark blue are likely to have or be versioned and have a independent life cycle from each other. So my containerized application, because of its high level of unit testing, may have an awful lot of releases or builds through a given time. It may be updated more regularly than my z/OS application. But if that z/OS application changes, because everything is using it, everything also needs to be retested. So the containerized application, we need to get the latest version of that containerized application, and we need to construct it and run it and run our tests through it to ensure that no changes that we introduce in the z/OS application have changed that containerized application. Sorry about that. So how do we start in kind of approaching some of this? When we spoke about the different types of application, we spoke that often the more modern, the more containerized the application was, the more chance of having a set of unit tests or automated tests for that application there were. So we've already got a level of capability there. But as we move down the stack and towards z/OS, we found that the amount of automated testing for those z/OS applications was fewer and fewer. Now, I'm not suggesting that we start writing a whole load of unit tests for z/OS applications. If you're writing new or you're changing the content of the z/OS application, writing unit tests to support that application or to support the change you've just made is absolutely the right thing to do if that capability is available to you. But the argument I'm trying to make is that the testing that we have on z/OS for or with our existing manual tests is the stuff that we need to have automated. Because if we can automate within a pipeline a set of tests that validate the quality of our z/OS application, then we can start to see a path forward to integrating that with the testing of the other parts of our hybrid cloud application. If we don't make this our first step, then we're always going to just be tickling the outsides of the application without actually really validating that the core of our application is still running. So let's automate the z/OS testing first, and then we use that value that we show that we can provide through doing that testing to expand the focus to cover the rest of the application. Now would be a good time for any questions if there are any, Rob.
We don't have any questions on the chat at the moment, Will.
Oh, that's good. So as a answer or as a solution to how to test these z/OS applications, we've been working on for the past couple of years a project called Galasa. And Galasa is an open source test integration framework that is provided under the Eclipse public license version 2. And the kind of heritage of Galasa is in the same technology that we use at IBM to test parts of the IBM middleware stack. So CICS, bits of z/OS, things like VTP, ODM are all either using the heritage product that we had originally, or are now using Galasa to test their applications. And Galasa is an integration test framework. It has the ability to allow you to do solve all of the problems that we showed above. So drive a Selenium web UI, to interact with some 3270, to run a JCL batch job, whatever your requirements may be. But it is predominantly initially focused at doing the z/OS type of workloads, because that's where the majority of our customers need the most help in the shortest amount of time in automating those core z/OS tests. So a couple of weeks ago, we actually released 0.25 of Galasa, which was a release that we've not had for a long time, because we made some pretty big changes to the way that we actually build and we release Galasa, and it took a long time for those changes to be made. But all of that allowed us to come out with 0.25. So all of that capability, allowing you to test drive a Selenium web page, or interact with 3270, run a JCL batch job, are all provided through a set of Galasa managers. So a manager is an object within the Glasser framework that provides an API to a test class to allow it to run things against run things as part of a test. So for example, the Selenium manager. So Selenium manager will allow a test to interact with a web page, and it will abstract away from that test all of the concerns and all of the difficulties in, well, what web browser am I using? What resolution? Where is that web browser? How do I connect to it? It just says, here is the Selenium Java object for a web page. It's already been provisioned. Do what you want. And in the same way with 3270, it provides the test class with a terminal object, which represents 3270 terminal, which we've already connected up to a mainframe. We've validated that the connection is good, and we're now ready to for the user or the test to interact with that terminal by entering things on the screen, pressing different PF keys, and we'll show a lot more of that in a minute. But I split this page in half, and the first half is all talking about the ZOS managers, because that is the core competency behind Glasser. Yes, being able to interact with GitHub issues and drive JMeter and do, interact with Docker and Kubernetes is all very cool and very valid things that a test might need to do. But I think, especially for this type of audience, the ZOS managers are far more interesting. So the ZOS managers that we currently provide through the project allow a Glasser test to interact with 3270 screens, submit JCL jobs, interact with ZOS, the ZOS file system, interact and run a kicks command, check if a transaction is enabled or disabled. This isn't a complete list, but the point I'm trying to make is that there's a set of ZOS managers that really allow you to have first-class access to a ZOS mainframe to start building that set of automation. And then as the testing that you want to achieve grows, then the managers that you can add in to Glasser allow you to expand your test views. So you can now drive API tests. You can understand the status of a work item in GitHub. You can run a Docker container. You can drive a Selenium script. And this manager architecture that allows these managers to work together within the Glasser framework and provide this capability to the test is part of the open source project. This means that vendors, it means that you yourself can write new managers that extend Glasser even further. So if you have a particular tool or capability that you use, so I was working with a bank, and they had a way of they had a set of scripts that they could run that would generate test data. And one of the things they've done is they've wrapped that test data generation with a set with a Glasser manager. So now the test can just go to the Glasser manager and say, go get me some new test data. That drives their set of ZOS scripts that build that test data. It pulls it back and it provisions it into the test, so that each new test has a new user, a new set of data to use as part of that test. Sorry, I apologize for the pauses. So like I said, in end of January, we released 0.25.0 of Glasser. And we made quite a lot of changes. I think it was one of the biggest releases we've ever made in terms of the amount of managers and things that were touched as part of 0.25. It was quite a wide-ranging release. But one of the things that we did that we had to have in place so we could build 25 and validate that it was working by building the 25 release was to externalize all of our bleeding edge repositories. So whenever a change is merged into our source code repositories, we run a build. And before we were running that build and we were consuming it internally on our side of the IBM firewall, which meant that people wanting to consume Galassa, wanting to test a fix that they'd raised an issue about, had to wait for the next release. If someone wanted to build or create a new manager and wanted to make sure they were building with the latest version of Galassa, so they were up to date, then they were just getting new code dropped once every release, and that could break what they were doing. So what we've done is we've now made our latest builds external on developer.galassa.dev, so that anyone can clone any of our repositories and build them straight away. And so that is the latest level of Galassa that isn't yet released. It's pre-release code. Another thing we added was around about the testing of color or the highlighting of characters on 3270. This was a US customer's request. They'd been using Galassa. They'd written a set of 3270 scripts or test classes, and they wanted to be able to update a 3270. Sorry, they wanted to be able to test the color of a character on a 3270 screen. So we added that capability in for them. And that was a really interesting story, actually. I should mention that. One of the people we had doing some work on that was a new graduate that had come into IBM. Another gentleman wrote the majority of the code, but we needed him to kind of test it and make a few changes here and there. And his one of the first things we asked him to do coming out of university was to start looking at 3270 protocol and syntax. And he seemed to really enjoy it. So that was our story of having a graduate come in and do some quite complex ZOS specific work, but really seemed to come out the other side enjoying what he was doing. We also updated our CLI. Over the past few months, we've really started to understand the power of a CLI to actually bring a consistency to everything we do in Galassa. Previously, we were very much Eclipse focused, and I can see that now changing over time. When we first started Galassa, we were Eclipse and Jenkins orientated, and we had a Jenkins plugin that ran tests in the Galassa ecosystem, and if you were writing those tests, you could use Eclipse. And I think we're now seeing a change that's been kind of instigated by a lot of our customers, in that a lot of our clients aren't necessarily using Jenkins as their CI. They're using Azure, or they may be using Tekton, or they may be using something homegrown. And we simply can't be providing plugins for each and every single one of those CI pipelines. So instead, we introduced the Galassa Control CLI to allow you to interact with a Galassa ecosystem, run tests as part of a CLI. Well, we've now extended that CLI to start providing support for you running your test locally. So we're still doing work on that in the 26 release that will be out soon. But our hope is that we're not going to be necessarily removing Eclipse, but we're going to be allowing you to write your Galassa tests using whatever IDE you want to use, be that Eclipse, be that NetBrains, be that VS Code. And that will all be powered through the CLI. We also simplified access to local test artifacts. And this was a bug that had been in the product for ages, that required you, if you were going to be looking at a resource inside a bundle, your test bundle, you had to have 2 resources folders nested underneath each other. It looked a bit weird, it looked silly, and we've now fixed that and got rid of it. So we've jumped straight to the summary slide. We should have gone to the demo slide. So we're at the demo slide now. So what I want to do in the next kind of half hour is I want to take you on a journey. I want to show you writing a Galassa test without using any of the IDE plugins. I want to show you running just from the CLI. So this means I can bring my own test, and we're going to start kind of writing a test from scratch. We have got the SimBank examples. And I'm going to quickly just show you those SimBank examples. If you've never used Glasser before, I would strongly invite you to download the Eclipse plugin and to have a look at these SimBank examples. Now, what SimBank does is it provides you with let's just get it running. We'll create a new run configuration. Glasser SimBank, it's already there, we'll run that. It provides you with a basic application, which looks very much like a 3270, looks very much like a 3270 or mainframe-esque application, but it's not, it's running on your local machine. So Host on Demand, helpfully opening things up on the other screen, which is always very helpful. And we call this application SimBank. So it's going to be running on my local machine, so 127.0.0.1. And it's going to be running a destination port on port 2023. So we'll just fill that in, hit OK, and run that. So this is what it looks like. So not a real mainframe, running on my local machine, 100% written in Java, and I can log on to it, IBM user, and I can put my password in as sys1, and I get to some sort of like splash screen. I can press PF1, get into a Kix region. I can type bank, which is my transaction, and there's a whole set of tests that drive this capability. So let's try running one of them quickly. Okay, so that ran. And then you can see here, I've got my run log. And you can see some screens that came through. This is what the test did. So this is all running this piece of test code, but from inside of Eclipse. And this gives you, through these set of samples, we do things like running batch jobs, making HTTP outbound requests, gives you a good idea of the types of tests that you can run with Glasser. But what I want to do for the rest of this demo is to kind of say, well, I've learned that, because these are great examples to learn from, but they're not very good for kind of writing your first test, because they are hard written to obviously test the SimBank example. So what I want to do is say, okay, I've done that learning with SimBank. How do I now move forward and write my first Glasser test? So let's close down SimBank and we'll start doing that. So the first thing I've done is I've downloaded the Glasser CLI tooling, and it's available from GitHub and from glasser.dev. And I'm in a folder here called demo. It's empty at the moment. And what I want to do is I want to get Glasser control to build me a test project. So before we had these instructions on our website, but they were quite, although they were quite easy to follow, there was quite a lot of steps, very easy to make a mistake, very easy to get things wrong. And if you wanted them to create another new project, it would take just as long again. So we've taken all that and put it into a command line tooling. So I can just run Glasser control. In fact, I am going to cheat a little bit. I've got a little crib sheet that I'm just pulling up that will make sure I don't get this wrong. And I'm going to Glasser control. I'm going to pass it the command project create to create me a brand new project. And I wanted it to create a project with the package name of glasser.gse.demo. And we're going to test a feature called CEMT. I want it to create a OBR, which is basically just a project that in the Eclipse plugin we constructed behind the scenes for you. But when you start to deploy these tests into a CI/CD pipeline, the OBR project is needed. So we've now kind of brought that to the front and made it, listen, that you do need this thing. Here's what it looks like. It's very easy to create. And I also want us to log the output of the command to the standard console. So just a single CLI command, I can run that. And of course I can't type. And instead of minus feature, it should have been minus features, because I can supply this as a comma separated list and I can test multiple features. So we'll run that command again. And it's all worked. We've been given a set of output telling us what it's up to. We've been told at the end the exit code was 0. All is good. All is fine. So what I'm now going to do is I'm going to open up an editor. So I'm going to pick IntelliJ IDEA. I've got no affiliation with IntelliJ in any way. This is their community edition of their editor. Could have easily been VS Code or what, I don't know. Hell, if you want to do this in Notepad, you can do it in Notepad. And I had a similar named project opened earlier, so we're going to open up that project inside of IntelliJ. And I can come into here and I can see it's created a project with my package name, galassa.gse.demo.cmt. And I've got 2 test classes, test CEMT and test CEMT extended. Now, these are sample tests. They don't do an awful lot. Test CEMT is basically just going to, is just a very, very basic test to say, yep, Galassa came up when you run it. This runs and passes, Galassa's set up, everything's configured correctly, you're set to go. Test CEMT extended basically pulls a text file that's held in the resources directory here and just validates the content of it. Not very complex, not meant to be. We wanted to strip out a lot of the code from here to make these almost just things you could just throw away if needed. But let's just close them down, move that out of the way for the time being, because what I want to do is now, well, I've got these tests. How do I build them? How do I run them? So I'm in the demo folder. If I do a list inside of here, we'll see that I've now got a new folder, which we just opened inside of IntelliJ. So we'll change into that folder, cd galassa.gse.demo. And I can see my projects in there. To build this, I'm going to build it using Maven. We are planning to support Gradle for this later, but for now it's Maven only. So I'll just type Maven clean install. And that will go away and run Maven, run Java to go and build this project. And the point of showing you this is to show that this is just a normal Java project. It's built using common Java build tool chains. There's nothing Z specific here. All of the things that it needs from Galassa are in a M2 repository, so they're easily provisionable for the builder. So I've built my code. That's great. Now I want to run it. And this is where it gets a little bit weird. I do, at the moment, if I want to run this outside of Eclipse and not within an ecosystem, I need to use a fairly complex looking Java command. We have got work going on this iteration to simplify this massively. So it will be a call through GalassaCTL to say run local. And I was hoping to get a Skunkworks version of that to show you today, but unfortunately, like I said, I've been ill, not been able to get that work done. So it's the Java minus jar version, unfortunately. But once that's released, it will be a command very similar to Galassa control project create that we used to create the project in the first place. So I've got the command, and all this is doing is basically starting up Galassa and then saying, go run that test for me. And okay, we got the same kind of output that we saw in Eclipse because it's the same style of test. It's the same framework. And we can see that the test class has indeed passed. All is well. But that was just doing a very basic test of just find a file that we'd already shipped and check it has some content into it. Let's get this talking to a real ZOS machine. So we're going to have to go back into IDEA, and I managed to close that project. So we'll just reopen it. Git documents, Galassa demo, GSE demo, open. And what we're going to do is we're going to change this test CEMT extended class to do some new things. Let's just move it out of the way again. Over here, I am connected to a mainframe running in Hursley. So not on my local machine, knocked up in Java, real ZOS, real Kix region. It's CEMT inquire system. And yeah, real Kix looks fine. And what we're going to do is we're going to do two things on it. One of the things we're going to do is we're going to run a transaction called GSE. And we're going to check that when we run GSE, we get hello world. Okay. I know it's not a very big test case, but it's meant to be showing you the kind of things you can do. And also, I've only got about 20 minutes left. So we need to be able to get this bit done in 20 minutes. So I want to be able to prove I can run that transaction and see hello world. The next thing I want to do is I want to check that if I run the Keki command, so Keki write Q TSQ, can't spell, U GSE from hello. Is that going to work? If I run a command like that, using Keki inside of Kix to drive a command that I can then use something like CEBR against that Q to check that my write actually worked. Okay. There may be questions about, well, why are these valid tests? Why would you be doing this in a real test? I will explain these things, but I want to get to the code and show you how we make this test run for real. And then I'll explain those things. So where's IDEA gone? It's there. Right. So the first thing that we're going to do is we're going to have to add some new dependencies. The test that we got given is fine, but it's not using any of the managers that we know we need to use. Here, we're going to need to be using the Kix manager and the ZOS3270 manager to be able to interact with a terminal screen. So I'm just going to open up the POM. And I am going to add in some dependencies. So I did have them. No, wrong place. I want to add them into here. So paste that in. So we're going to say we need a dependency on the Kix TS manager and a dependency on the ZOS3270 manager. So we'll save that. So what's that going to do? That's going to basically mean that when we build and run this code, we have the ability to use those managers within our code. And we don't load all the managers for every test because not every test is going to use all the managers. So we kind of provide a subset of available managers. So we've got those managers. Let's go back to our code. So the first thing I'm going to need to do is declare that I want to interact with the Kix region. I'm writing a Kix test. I need to interact with the Kix region. So I'm going to do that by adding a new annotated element. So I'm going to add a new @Kix region, which will give me a annotate with @Kix region, and that will inject into the test at runtime a iKix region variable for me called region A. I'm also going to need a couple of Kix terminals. So we'll add them in as well. Now here, note that I've not said where what this Kix region's Apple ID is, that these terminals are of a specific size. All of that is going to be handled for me when I run the test using a set of properties. This means that I can allow the test to be unchanging and from different test releases. And it means I can run this test against a virtualized ZD&T environment. I can run it against a real Kix region without any changes. So we're going to save that, and I'm going to flick back over to here, and I'm going to make sure that I've not made any changes that are going to cause my test to fail. So I'm just going to run that maven clean install command again. A couple of seconds. Oh, I got some problems. We cannot find some symbols within the test class, and that's fine. Now, I kind of knew that because these were all red. Well, this is just basically a case of that we've not imported the classes into our code. And Eclipse kind of sometimes does this for you. IDEA sometimes doesn't, especially if you paste code in like that. So let's go back to our output and just redo that clean install. Excellent, build successful. So now let's try and actually use those objects we've added to run a test and to run that GSE transaction. So I'm going to paste in this piece of code, a new test method, GSE transaction test. So I'm going to go to my main terminal. I'm going to type GSE. I'm going to press enter. I'm going to wait for the keyboard to come back. I then want to assert that when we retrieve the screen, it contains hello world, and then clear it. So basically run the transaction GSE and test that we see something back on the screen. So we'll save that. We'll come back to our terminal. We'll rebuild. That's very strange. Okay. So we're getting some compilation errors on these pieces here. And I think that's a very strange issue, because that class does extend Kix terminal. So why that's not working is very interesting. Let's put in the other piece of code. Okay, so that's a bit interesting. I'm not quite sure why that's happening. It definitely wasn't happening before. Just give me 5 seconds. I'm going to try and just work out what I've not done properly that is causing this problem. Were there any questions?
No,
Rob?
there isn't.
Oh, is that Jenny?
Yes.
Oh, hey, Jenny.
Hey.
Okay, so there's obviously a problem in my code there that wasn't when I played with this morning, but now is obviously there. So what I'm going to try and do quickly is let's just try rebuilding that. Yeah, one thing it's not going to like is I didn't have a end brace there. Okay, I think I know what I've not done correctly. If you just bear with me, we will get that fixed. Okay. Yeah, so I think we're going to have to ditch that demo. And what I'll do is I'll record that at a later date and I will show you what that was going to do. But we can explain the code. So basically, the code that we were going to run was going to, like I say, type on the screen GSE, press enter, wait for the keyboard, retrieve the screen, and ensure or assert that it contains hello world. The next thing the test was going to do was going to type Keki on a terminal and then basically use the Keki manager within the Kix manager. So basically going to the provisioned Kix region saying, get me hold of Keki, then issue the command exec Kix write QTS from hello. And then basically it will check and it will run that command and check we got a good response normal, that Keki was happy with the call, that Keki was happy with all of the input we've given it and that the command had run successfully. And then on our other terminal, we would type CBRGSE, wait for the text in the field, say top of queue, and then ensure we saw the message that we'd written from the Keki command at the top of the temporary storage queue. Why was I showing these things as being important as part of our test? Well, obviously being able to run a transaction and check things on the screen and drive that terminal logic is a very valid thing to want to do as part of our ZOS test. But why do things in Keki or CEMT or CEDA? Well, we're not expecting that Glass is used to actually drive the deployment of your Kix application, but it may be needed to drive or create negative or error scenarios, maybe artificially installing a T-class, maybe disabling a program or disabling a transaction and see how that affects the rest of the application. So that's why these types of methods and the functionality we've added in with Keki and the 3270 manager allow us to do that. So let's just switch back to the slides. So in kind of summary, testing that large, complex hybrid cloud application is very difficult. It's a very difficult proposition. And since all of those flows of information and flows of data go through the ZOS application, it's important that we've got the testing of that ZOS application right first. Do we have enough automation of that application before we consider everything else that's going to drive it? And then we kind of just introduced and talked through Galasa has an open source offering allowing you to do the automation of some of those Kix parts or the ZOS parts of the problem, and then allowing that test to grow to uncover other parts of the enterprise application as well. So we've got 6 minutes left. So if you've got any questions, I can take those now.
There's nothing in the chat, Will. So you're off the hook. How are you feeling?
Yeah, I'm okay. I'm out of tea, so next time I cough, it could be for a much longer time.
Okay. I hope it hasn't got too cold on you. Thank you so much, Will, for doing this. I really appreciate that. Jenny's just posted the feedback link, which is brilliant. We're back in an hour or so at 2 p.m. With Stu, who's got another session with an equally long name, which I'm going to have to look up because I've only written it down in abbreviated fashion. Just bear with me a moment, folks. There we go. And yeah, so it's very much development related, cloud native Kix application development and deployment with the IBM Z and cloud modernization stack. So even longer title than this one. But thank you, Will. I think a lot of people are kind of interested in this. And one of the things that we do need to do is try and reach out to the testing community a bit and try and get them to plug into some of these sessions. I know we've tried here, but
yeah, and really sorry that demo didn't seem to work. I was working on it just beforehand, and everything was fine. And then yeah, the ID just decides it doesn't want to play.
Very capably with it, Will. So don't worry. Thank you very much again. And thank you, everyone. I'm going to close the session now, and I'll see you back here at 2.
Cheers, everyone. Bye.
Thank you.
Cheers. Bye-bye.